All right, so let's look at the first problem off of 13.10. We'll make sure you're doing okay on these and just give you another example of how we can start to calculate these types of problems. You'll notice because it's the Word doc, I got the ability to kind of manipulate. Feel free if you would rather work on a separate sheet of paper, that's totally fine. Whatever makes the most sense for you as you're working through these. It's probably going to be a separate sheet of paper type of deal, but I want to kind of make sure you can see where my work is going as we kind of work at this. Cool. So let's start by taking a look at what information we actually have available to us. We know we've got a 6 molar calcium hydroxide solution that has a density, sorry, I'm trying to grab my little wrist guard here, a density of 1.25 grams per milliliter and a volume of 2.40 liters. Determine the following pieces of information based upon the information provided. So the first question is asking for the total mass of the solution. Well, I think our formula that deals with mass is our density. We know that density equals our mass over our total volume. So for this particular piece, we know the density is 1.25 grams per milliliter. Do be careful here because we don't have milliliters provided. We had the liters provided. Well, real quick, we could change that into milliliters. I think that's probably going to be the easiest here. We've got 2,400 milliliters. The question is, what is the total mass? Okay, so we multiply those two values together. When we do, it comes out to a very nice, clean 3,000 grams. Uh-oh, sig figs. We need 3 sig figs. One of the ways we do is put a little bar over that 0 we want significant. We start counting with that and everything after. You could also do 3.00 times 10 to the third gram. Both of those would totally be acceptable. But there is our answer for our first calculation. Cool. Second question says, what is the mass of just the calcium hydroxide in this solution? Well, we would need to know some stuff. If we go back to our molarity, we know that molarity equals moles of just our solute over the total liters of our solution. Well, we know the molarity was 6.00 molar. We don't know how many moles are in this particular solution, but we do know the liters. The liters was our 2.40. We multiply that up to get just our moles of our solute here. When we do that math, we come out at 14.4 moles of calcium hydroxide. Well, that's not what we wanted. We wanted mass. Well, moles to mass is pretty straightforward. We would need to know the molar mass of that substance. Molar mass for calcium hydroxide is 74.0. Sorry, let me get my decimal there. 0.096 grams. We would multiply those two values together to get the grams of just our calcium hydroxide, and that would come out to our 1,070 grams of specifically our calcium hydroxide. I'm going to make a note of that so that we don't get it confused, because up here we've got the total mass. Now we've got just the mass of our solute. Oh, well, okay. C says, what's the mass of just the water in this solution? Well, we know the total. It was at 3,000 grams. We're going to subtract by our mass of just our solute, which was 1,070 grams. That will give us just the mass of the water in this particular solution, which comes out to our 1,930 grams of water, of our H2O. If you're looking at our sig figs, when we subtract, look at decimal places. We were to the tens place here, to the tens place here. Report our value to the tens place here. Cool. Molality. Molality is little m. That's going to be moles of our solute divided by kilograms of our total solvent. And we know from up above we had 14 point, sorry, let me find it real quick. Yeah, there it was. We knew from up above we had 14.4 moles of our solute, 14.4 moles. We just found our mass in grams. Quick conversion turns us back into 1.93 kilograms. Moles divided by our kilograms here gives us a molality of 7.46 molal is how you would say that little m for our solution concentration. Cool. E is a little bit different. E says, what is the molarity of just the calcium ions? just the calcium ions. Well, that's asking us about this particular solution up above, isn't it? Well, if we know the molarity of the whole thing, for every calcium hydroxide, how many calcium ions are there? Well, there's only one. So it's all kind of one-to-one relationship there. So that molarity would be the same. It's going to be 6.00 molar for just the calcium 2+ ions. But for every calcium hydroxide, you get 2 hydroxide ions in solution. So for just the hydroxide ions, it would actually be that 6 molar doubled. So it's going to be our 12.0. Sorry, let me get my decimal in there. Molar on our hydroxide ions. Cool. Good example of all these calculations. We start to run them all together. A couple more for you to practice. If you got questions, come on back and we'll get them all answered.